Okay, all right. Welcome to the Python Bootcamp and people who have joined new. So this is a Python series which we are doing, and we had two sessions before which covered the basics of Python. So this is the third session where we'll be looking at other advanced stuff in Python. So if you are a beginner or if you are still learning Python, don't worry about that. So I'm trying to teach in a way where it is easy for everyone to understand. Okay. So with that, we'll get into the agenda. So this is the 4 week agenda we had. And I have already covered the first week and second week where I went through the Python basics and intermediate. And these two videos are already available online. Janardhan will be putting the links out in the chat later. And today we'll be covering on week 3, which is all about data handling with NumPy and Pandas. Okay, so NumPy is a library in Python, and again Pandas is also a library in Python, which we spoke about libraries before in one of the session, and we'll be using that to learn about how data manipulation or any kind of data operations are done in Python. Okay, and once you are familiar with data, you can then understand how the same data is used in terms of AI. Okay, so the main important thing in any of the AI products or any of your LLMs is that data has to be correct. So we are looking at the data here first, and then we'll be jumping into the world of AI. So with that, so there are some kind of expectations from learners which we have. So Python is like very easy language to learn, and you have tons of resources online. So as Janardhan pointed out, we use tutorials point for reference. You can go through that particular website and try to learn from there as well. And the most important thing for any of the programming language is that you need to get your hands dirty and play, which means that you have to do a lot of practice to understand what is happening. Okay, and we also have a Discord server, and we have a WhatsApp a group created where you can join and you can always ask questions, and we'll be happy to answer that. And the most important expectation from everyone is that you have to be curious to learn new things. Okay. So with that, we'll jump into NumPy, the first topic for today. Okay. So what is NumPy? Let's look at what is NumPy. So NumPy is an open source Python library, which means that it is freely available, and anyone using Python can use NumPy. And why is it used? It is mostly used in science and engineering, numerical computing. What it essentially means is that if you want to do any kind of computation or numerical analysis, you can use NumPy. The basic example I can give you is if you're adding few numbers, right? If you're adding few numbers like 2 plus 2, or if you're adding some numbers from your bank account, you're trying to say I received some amount in my bank. It's very simple mathematics, right? It's not complex. But when you go further into mathematics, you find much higher kind of calculations being done. So the example here you can see it's kind of a cricket analysis where we are trying to predict the player, and we create some kind of models, and all these things can be done with NumPy. So we'll be looking at few of these things here in this session today. And you can also see that NumPy is mainly used with multi-dimensional arrays or matrix. I will not jump into what are multi-dimensional arrays and matrix right now. But if you are aware of arrays, it will be easy for you to understand that. And the way we try to do some kind of mathematical operations on them. So NumPy stands for numerical Python. Okay, that's so it's easy to remember. So anything numerical you do with Python or numbers, it is covered in NumPy. Okay, and it's able to handle a lot of large data sets. So when you're working with something like this cricket data here, it's not some small data, it's a huge amount of data where you have a lot of statistics about players or your other any kind of other statistics within the field which is happening. So all those things can be handled with NumPy. Okay, so let's jump into who uses NumPy, like where all it is used. Again, as I said, it is mostly used in scientific simulations and modeling. People use it in physics or chemistry to model some kind of atoms or some kind of chemicals, and all that can be done, and then you can calculate based on that. It is also useful for doing some kind of transformations in data. So we'll be looking at data transformations today, and also a manipulation of image data. So when I say image data, I can give an example, like if you take a picture and later you can apply some kind of filter, or you can apply some kind of color to it. So all those in the background is taken care by the NumPy libraries. So again, when you take a picture, it is just pixel. Pixel is again your bits, right? And the kind of manipulation that happens with these bits can be done with NumPy. Again, jumping into finance and economics, here we have NumPy being used for some kind of market pricing or economic modeling, and all that we can use this. We can again, like I said, NumPy is usually used to simulate some kind of numerical calculations, right? With that, just getting to know what is NumPy, we will jump into the code and try to see how it is done. So for this demonstration, I'll be using Google Colab. Okay. So for people who are new to this session, we are using Google Colab. So Google Colab is a free tool provided by Google, where you can run your Python code. Okay, and it's free. All you need is a Google account, and you can run your programs here. Okay, so I explained about this in the first session, and I will not go through the whole thing again. But with Google Colab, you can directly come and run the programs here. So the first thing you can see here, that I am importing a library for NumPy. So as we saw in the previous session, we use this import keyword. We say import NumPy as NP. NP is an alias. We are trying to say that instead of using this whole big word of NumPy, we are saying use it as NP. And once we import that, we can start doing these operations. And one thing to remember is that NumPy is not part of the standard Python library. We need to import it, in the sense it downloads all these libraries, and then we can start working with it. Okay. Before I jump into this, are there any questions? So we can quickly go through any questions before I start into these operations of NumPy. Janardhan, are there any questions?
No questions for specific this topic so far, Sumant.
Okay, all right. Let's jump into the operations part. So how do you create a array? So NumPys are all about arrays. So if you have learned about arrays in
Chinmay, you have a question?
Yeah. So sorry. My question is, like, is NumPy primarily used for only data specific purposes, like where there is a
Yeah.
lot of numerical data, or can it
Yes.
also be used for any some other kind of computations which doesn't? What I mean to say is, like, not that much data, but still some deep mathematical calculations or programming.
Yeah, you can use that. It's any kind of mathematical or numerical calculations you want. This is the base. So other libraries, which I'll talk about later, are built on top of NumPy. So NumPy is the base library, and you can use it for small calculation or bigger calculation, however you want. You can use that.
Got it.
Okay.
Are there any other comparable libraries?
No, these are the top libraries which are easy to understand. So everyone like out there uses NumPy.
Got
You
it.
can go and find online, but everyone, like for beginners and as well as professionals, use NumPy, as it's much easier to start with.
Oh, good. Got it. Thank you so much.
Since many people are using Chinmay, they are also optimized and kept up to date for different kind of using parallel processing and GPUs and others. So that's why these are very useful, the most popular ones.
Understood. Understood. So as a beginner, it's usually overwhelming to start with. So I used to work in research earlier, and there we used to start with Mathematica, which was not that easy to handle, easy to learn, Mathematica or MATLAB. But here you say that NumPy is not doesn't have that problem, right? Even beginners can easily get a grip of it.
Yeah, correct, correct.
Okay, thanks.
Okay. Okay, we can guess move on. So I have this NumPy array. So we spoke about arrays in our previous session. What are arrays in Python? The same way we can create a NumPy based array here. So I say NP, which is the NumPy alias NP dot array, and I give the elements. So it goes ahead and creates this array. So the thing about NumPy arrays is that if you go in deep, in the memory of Python, it stores them together in a single continuous array of blocks. Okay, so all these are next to each other in the memory is what you can think. Okay, so it's easy for retrieval purposes and all. Um, and when you say that you have created this particular array in NumPy, it has its own data type and other values assigned to it. So you can go and have this type of array. I can check what is the type of array, and it says that it is the type of NumPy dot nd array, right? So this is not the normal Python array. This is the NumPy array. So you can find out if it's a normal array or a NumPy array using this type function here. And also you can find the shape. The shape is I'll talk about shapes later, but the reason why we are looking at shape is we want to know how many elements are there in this particular array, right? So there are 5 elements. Okay, and this is useful when we jump into matrix next. With the NumPy, you can also create matrix. So right now we are also jumping into bit of mathematics. Okay, so if you are familiar with math and all, so it will be easier for you to understand. So there's a concept called matrix, right? And if you have heard about it, we can create a matrix in NumPy. Okay, what it uses is a multi-dimensional array here. So you can see that we have two values specified here, 1 2 3, which is itself in square brackets, and then you have 4 5 6. So this in programming we call it as a multi-dimensional array. Okay, or we call it a 2D array, and we can define that in NumPy as np.array, and we can add these values, and we usually call it as a matrix. So this is how it is printed. If you have written a matrix, you know that it has these rows and columns to it, and you can also get the shape of the matrix, right? So when I say the shape of the matrix is that there are 2 rows, so that is 2 comma 3, which is there are 2 rows and 3 columns here. So like I said, NumPy is more of a numerical calculation library, so there will be a lot of math related topics. So if you get confused, you can always ask questions on that. Okay. um, And next, we can go into how operations can be done on this kind of addition operations or multiplication operations. So I have 2 arrays, again NumPy arrays here, and I can add them and I can multiply them using the standard operations here. So plus array 1 plus array 2 gives me this result, pi 7 9, and multiplication gives me this 4 10 18. So you can see that here we are multiplying element wise. So 1 is multiplied with 4, and 2 is multiplied with 5, and 3 is multiplied with 6 for this particular array. The same way we can also have mathematical functions in NumPy, where we can get the square root of that values in the array. We can say np dot square root. It gives the square root of all these values. We can also have a sine function. Again, sine function comes from your trigonometry, where we can get the sine values for these array values. Okay. Again, it might be confusing for some people because we are jumping into a bit of math and Python. Don't worry, like you can always go into tutorials point and try to understand, read more about what NumPy does, and if you have a good grasp on Python basics, it will be easy for you to understand. Um, Okay, again, going forward, moving forward a bit, again, are there any questions? Because this whole session it will be a bit confusing for new learners. Are there any questions, Janardhan?
No questions in chat. We'll
Okay,
check.
uh,
Yeah.
sure. Again, so in math or in Python, or if you go into ML like machine learning and all, sometimes what happens is we want to create a matrix of zeros. Okay, we just want some kind of zero values to be added. So in that case, we use this numpy dot zeros and we give the shape. I talked about shape, right? So this is the row and column, and I can get this whole matrix of zeros only. So again, these are applied elsewhere when we are doing some kind of complex operations or complex mathematics. We use these zero matrix for some kind somewhere. So this is helpful for that. And we also have numpy.1s where it gives the values of 1 in each of these matrices. Okay, so again, I'll not go too deep into where it is used directly, but I can tell you that it is used mostly in machine learning and other algorithms and all. We mostly use this. Next is range. So you can create a range of values here. I have something called np dot a range, array range of 10. What it does, it is that it gives me the whole range of 0 to 9. Okay, I get 10 numbers 0 to 9 with this particular thing. And the same thing here with np.a range, 0, 10. I want numbers from 0 to 10, but I want to step it up by 2. So I want the numbers for every second step. So I get like 0, 2, 4, 6, 8. Okay, so these are also some things, some logic you can use in your calculations. Okay, and then coming back to matrix multiplication. So what we saw was the simple array addition and multiplication here. And now we jump into the actual matrix multiplication. Um, Actual matrix multiplication is a bit different. I'll not go into the theory part again, but I have these two matrices here with these values. And when I run this, I get the dot product. So we usually call the multiplication as dot product. We can either use matrix 1 then at matrix 2, or we can say numpy dot, which is the dot product function of matrix 1 and matrix 2. Okay, so the dot product of these two matrix is this value over here. So you can see it is 19, 22, 43, 50. I'll not go back into the theory of how it is done, but we usually again use this for a lot of again ML related calculations and all. We also have something called as a transpose of matrix where it flips these values. I am doing the transpose of this first matrix here. So I do that matrix 1 dot t. It's a transpose. What it does is it kind of flips it. So I have 1, 3, 2, 4. Okay. So let me I also can do a inverse of a matrix where I apply this inverse function to this particular matrix 1, and it gives me this value which goes back into negative. So these are again very fundamental math based operations which we can do with NumPy, and it gives a lot of libraries. These are very basic things which I'm trying to just showcase here. There are more than these libraries available. Next, we come to some kind of linear algebra. You can also do linear algebra problems in with NumPy. You can see this. This is the function here. So we have 2x plus 3y equals 12, and x plus y equals 5. So we are trying to solve for this particular linear equation. Okay. The way we write that whole thing is using NumPy. We can write the coefficients here, and then we can define the constants in another variable, and then we apply the linear algebra to solve this. Okay. Again, if you don't understand, don't worry. You don't have to jump into all this to understand. We'll be, as I told, NumPy is a very base library, and again, you have a lot of abstractions built on top of NumPy to ease the things out. So it gives you also the power of linear algebra. So I can get the values of these linear equations with this. Okay. And yeah, before I jump into the next, any other questions?
Yeah, we're able to answer, but you can also talk about, so two-dimensional matrix and data frame. What is the difference?
Yeah, data frames I'll explain in the next section, which is pandas, not right now. So just wait for pandas and I'll explain there. Okay. Yeah.
Okay.
Okay, let me just cover all these. So in NumPy, we also have some kind of trigonometric functions as well. So when I said that NumPys are used in engineering, and also engineering mathematics again uses a lot of trigonometric functions. NumPy provides all these functions here. So if I try to run this, it gives me all these values. So you can read about this, like how these are done. And so this example is easy for everyone to understand. So this is like the stock price example, where I have a bunch of stock prices listed in an array. Okay, and I want to calculate the mean price of these stock. So I have something called as numpy.mean. It gives me the mean price. Then I also have something called as the cumulative sum. Okay, so cumulative sum is it keeps adding the successive values. So it gives me the cumulative sum. And if I run this, so it's easy to understand how these are also used in financial computation and all. This is a very basic example of financial computation here, but like you can go advanced with these. Okay, and now this one is bit complex again. I will not explain the whole thing, but if you have heard of fast Fourier transformation, so it is used in signal processing. If you have any kind of radio signals or Wi-Fi signals or anything, the way we can calculate those is using the fast Fourier transformation, and this is like a small program for that. The thing I wanted to demonstrate here is after doing the calculation with NumPy. Okay, there are a lot of operations here. After doing the calculation, we can plot the values. So we are using a library called plotlib. Okay, plotlib. Okay, this is a different library to plot these values. You can see that this is the original signal, and I have this particular visual representation of that, and then I have this result of fast Fourier transformation where it is compressed. So these things can be defined here, and what I wanted to demonstrate here is that after doing any kind of calculation in NumPy, you can use these other visual libraries to showcase like what is the result. Okay, so if you go through these, you have a couple of again functions here like the plot and x label, y label, where you can define these graphs here, and you can showcase it, right? Yeah, so this was like mainly about how NumPy is used in Python. This is a very, very basic introduction, not going into too deep. Okay. Yeah, so are there any questions on this before I jump into the next?
Yeah, so far we are good.
Yeah, okay. So next I'll be jumping into pandas. Okay, someone was asking the data frame and all about it. So pandas. So what are pandas? Again, pandas is a library which is actually built on top of NumPy. Okay, so you need to understand that it uses NumPy underneath it as a base library. Again, pandas is open source and it provides you a lot of data structure and functions for data manipulation and analysis. You can again use this for to do all your transformations on data, or you can also do data visualization or your data cleaning, and there are a lot of things which can be done with pandas. Okay, like I said, so pandas offers you two types of data structures, which is one of which is data frame and the other is series. We'll be looking at data frame here. So essentially, what is a data frame? So data frame is a kind of a data structure where the values are represented as rows and columns. Okay, so people who are familiar with relational database, okay, you have a bunch of rows and columns, and you store the data in that way, right? The similar way, data frame allows you to store the data as rows and columns, and it's more easier to do operations on data when it is stored in a tabular format like a relational database. Okay, and it also like I said, it has data cleaning and data filtering, data aggregation. So all these functionalities are part of pandas, which are not directly available in NumPy. Okay, so we use pandas for higher level of operations. So, what can pandas be used for? Again, here, like I said, it can be used for data cleaning or preparation, visualization, and then you have something called as ETL. So, ETL is a data engineering process where you extract the data. So, the data can come from any of your files, or it can come from some database, or it can come from any of your service. So, what you do is first extract that particular data, and then you transform it. Transform involves, the same kind of transformation functions where you kind of filter the data or aggregate the data, right? So there might be some data which you don't need for your analysis, that can be filtered out, or you can do some kind of other transformations which we'll be talking about later. And most of this is used in machine learning where you want the correct data. So machine learning literally relies on data. Okay, so you need the correct data to be available to you so you can make better predictions and all. Okay, so with that, we will jump into the code to see how pandas are actually used. Okay, and again, before jumping that, are there any questions? So someone had asked about data frames. Is this clear?
Yeah, thank you. Yes.
Okay, so jumping into data visualization with pandas. Okay, so like I said, in pandas you create a data frame. Okay, so we'll be doing that here first. So we have a map here. So we have a cars as key, and then we have these values, and then we have something as passing as key, and then we have other values. What I'm trying to do here is that I'm trying to do pandas PD. So I have the alias as PD for pandas. So PD dot data frame. I'm trying to create a data frame, and I'm trying to pass this particular data structure here. When I do that, this whole thing, which is, you can see it's kind of an array here, is actually converted into a data frame where it is represented as row and column. Okay, so I have a separate column for cars, and I have a separate columns for these passing. Okay, so that's how a data frame looks like. Like I said, it's a row and column data structure. Okay, and also, like series, what we get is we can create some kind of series here. So I'm saying pd.series, and I'm passing in the array, and again here also it is creating this kind of a column data structure. So the reason why everything is like a column and row data structure in pandas is because it's much more easier to operate on these type of data structures. And so that's the reason we convert it into a row and column format instead of just having it as an array. Um, okay, so this is another same example of creating a data frame from two columns here. So I have something called as column 1 and column 2. with these particular values, and I say pd.dataframe create this particular data frame, and it goes ahead and creates these two columns. Okay, and we usually say as a df is the data frame, and as a variable, and then we just print it out for now. And again, we can look at the different operations on this particular data frame. So we'll consider this data frames. So there are two columns here. Okay, and we can get only two rows of that particular data frame. I can say df.head, and I can say just give me two rows. So it will give me two rows. If I say three, it will give me the first three rows of that particular data frame. Okay. Again, we have something called as dataframe.info. So when I say info, it gives me a lot of information about this data frame. It tells me what data type are these variable themselves. You can see that it's a int64 data type, which means it has integer values here, and the whole data frame itself is an int64. And what is the memory usage? Because when we are doing a lot of calculations, we have really massive data sets. We also need to understand how much memory it is using. So all that information is provided by dataframe.info function here. Okay, and it also gives you the class of the data frame. So it is a part of the pandas.core frame data frame class. Okay, so if you are doing some deep analysis, this information will be helpful for you. And we also have something called df.describe. So it gives you some other values, like what is the mean and standard, and what is the, so these are again when you're doing some kind of financial calculation. At that time, these things will be helpful. For now, this is a dummy example, so it does not make sense here to use this df.describe. And you can always just select one column here. So I'm just selecting df and saying give me just column 1. If I want to select column 2 only, I can say df column 2, and it just gives me the column. Okay, I can also select by the row. I can say just give me the values which are in row 0 to 2, sorry, here 0 to 2, and it gives me these. Okay, and I can also do a filter operation. I want only the rows, the columns which have values greater than 2, and it gives me these values which are like greater than 2. Okay, so these are the kind of things which very basic things which can be used with pandas. There are a lot of other operations. You can go and check out the pandas documentation, or you can go into the tutorials point website, and they have a lot of other operations which can be used on data. Before jumping into the CSV part, are there any other questions on this?
There is a question from Prasad. Okay, doesn't Python have support for collections querying like .NET Link, LINQ? I do not know what it is.
I'm not sure. I am also not a .NET person. I have not used .NET. So maybe he's talking about collections in the sense like
Querying, more like SQL querying and linking and joins, those kind of things.
Yeah, you
Is that
have
right,
that.
Prasad?
Yes, you have that. If you are talking about SQL and all, yes, you have that option to query and all. But I have not included it in here because this is like more of a beginner friendly thing. Yeah, you can go and check the documentation. There are functions where you can directly do the select statements, and you can combine these columns together using joins and all. Okay, so you have, so one example I can tell you is that if you have two data frames, let's imagine this is one data frame and this is second data frame, and you want to join it like two tables in a relational database, you have that function to join using the join queries and all. Okay. Okay.
Sumant, one question is, can we define data type explicitly in data frame?
Yeah, you
Like,
can do that. Yes, you can do that. You have that function d type. You can do that.
okay.
So
Okay. Any more questions?
yeah. So whenever we fetch data from DB, So we always need to think about storing in a data frame, right?
Yes, correct. Yeah.
Thank you.
The reason why is that because it's much more easier to operate on it if you have it in a row
Mm.
and column format
Mm.
than having it in any other format.
Okay, thank you.
Yeah, if we have a large data set, would it work? Means if we
Yeah,
have,
yeah, it can handle any kind of large data set. There's no limit. Like the limit can be your like your system. Like it can handle massive data sets. No
uh,
issues with.
but if we are processing the billions of record using the data frame, what is happening internally where we are storing that data? Means it is in our
Yeah,
RAM.
so in the memory itself, it has a different format and all. Internally, you can go and check and read on that how it is
Okay,
used.
okay,
But you do when you can read on that directly. So I have not explained it everything over here. You can
okay,
go have a deep dive on that and understand.
okay. Thank you.
That's all.
Okay.
Continue.
Yeah. All right. So next is like we are you going to do go continue with the pandas itself, but right now what we are going to do is we are going to read from a CSV file. Okay. So I have this particular data.csv file with me. So this is a sample data file I have CSV. So Panda provides us with this function called read CSV, and I can read this particular file into a data frame. So someone just now asked if they'll be able to add all the values in this. So yeah, so you can have all the values from the particular file into a data frame. Okay, and if I run this, so here I have the same thing here, data frame, sorry, pandas.read CSV, and the name of the file. And if I print it out, it gives me this big file which contains different rows and columns. And this is some sample data set of duration, pulse, max pulse, and calories. Okay, some health related data set this is, and we are reading this, and over here same thing. What I'm trying to do is I'm trying to say give me the data frame dot head. Okay, so it gives me the first five values here. So by default when I say data from that data frame dot head, it gives me the first five values here. So I can try to take a peek at what is there in my data set here using this. And the same kind of function is we have data frame dot describe. It gives me the whole description of the data frame, like what are the values present. There are some so you can see that calories is actually a float type. Okay, and duration, pulse are again integer type. We can go and verify that. Someone was asking for the data type. You can see that this is the D type, which shows that this is a float and int. It contains float and int. Okay, so it gives you all that information. Then memory information here, the size of the file, and the same we have the same thing here. We have, yeah, so this is like filtering. So we are trying to filter out the rows which are greater than 60, where duration is greater than 60. If I try to filter that, I get these values. And here, yeah, so these are the values where the duration is greater than 60, right? So you can, so the whole thing was that you can grab the CSV files, or you can also read the JSON files. Or I think someone asked, like, can we read the JSON files? We can also read JSON file in pandas, and any kind of file. It's not just CSV or JSON. In place of this, you can also have your own database connection here, some kind of DB connection, right? If you have that, you can directly read it into a data frame. Okay. So again, using the same data.csv, we can have a plot. Okay. We can use the same matplotlib library here, and we are trying to plot this particular graph, saying that these are the calories and these are duration, and we are just trying to plot it out. So this also you can do it with pandas, because we have the data frame available with us and we are able to do that. Okay. And we can also have a kind of histogram. Okay, with the same data frame, we can say give me, I take the duration from the data frame and try to plot a histogram, and it gives me this. And again, this is a pie chart. You can create pie chart or this. So this is more of a visualization part of pandas, where you can take the data values and try to visualize it, so it's much better to understand. Okay. And so again jumping into this last few examples, are there any questions?
I have one question. Since frames library looks more advanced to me than NumPy, so can we like use data frame library instead of NumPy for the use cases shown
Yeah,
earlier?
yeah, you can directly use. I'm using pandas. This is a pandas library, not the data frame library. So we use the pandas library directly. Internally, it has NumPy defined, so you can directly use pandas for any of these operations.
That's why, like pandas instead of NP, we can
Yes,
use.
you can use. Yeah.
Thank
Okay. Any other questions?
No questions so far. Yeah, I think
Okay.
Prasad pointed that seems that there is a package for filing similar to querying collections and things. Yeah, thanks Prasad for sharing.
For
Good.
the JSON reader, do we have a similar function like CSV reader?
Yeah, yeah, you have that read JSON function. You
Okay.
have. You can go and check that. Yeah.
Okay.
One question from Subramanian, how to call PLT show from front end. So this is showing in the terminal, right? Or wherever the collab is.
Right. In the front end, right, this is not the front end. This is just the Python part. We, if you want the UI part, then you'll have to define it with the UI libraries and all, not with the Python libraries. This is directly we are using with the Python libraries, not the UI libraries. Does that make sense? Like, does that answer your questions? You are probably asking that you want to display these
Mm.
visualization in the UI part.
Yes, yes. So for that, we should use the HTML, and we have some frameworks also, UI
Yeah,
frameworks to show the graphs.
right.
Yeah.
Okay. Next, I have last two examples here. So this example has pandas and NumPy together. So we spoke about NumPy earlier. So what I'm trying to do here is that I'm trying to generate a date range from like 2023 January, and I have some particular periods of 100. It will, okay, and then I have some random stock prices. Okay. So this is again, I'm creating randomly. There's no actual price here. So I'm creating date and stock prices. What I'm trying to do is then trying to put these two into a data frame here. So again, I say pandas.data frame. I put this dates and stock price as two columns. Okay. And then I'm trying to set some index here, and then I'm using again the plot function here to plot the libraries. So here you can see this is just a sample again, where we can use these kind of functions to visualize the particular stock market prices or anything. We can use this similar way with pandas. And the next example is bit dynamic. Okay, so in this we are using a new library called yfinance. So yfinance is a library from Yahoo. If you have heard of of the company called Yahoo, they provide you with Yahoo Finance library. So I'm importing that particular library here, and again I have my pandas, then I have my matplotlib. Okay, so in stock market you have something called as a ticker. Ticker is your representation of the company. Like Apple company has this AAPL, and this TSLA is for Tesla. So these are the tickers through which they are identified on the stock market. Okay, and I can say that this is the start date and the end date. Okay, I want the stocks between these two dates. Okay, so if I use this particular library YF, which is the Yahoo Finance, I can directly download from their uh, you can say database or from their website, and all I have to do is I need to get that particular ticker, which is the stock name of the stock and start date and end date. And what I do is that I put it into a data frame. So this is my data frame here. I get the information from Yahoo and I put it in my data frame, and then I'm able to display this. This whole thing is like I'm trying to plot it out. Okay. So if I run this now, what it does is that it installs these libraries first. Okay, and then it gives me this whole information, like a visualization of all the stock prices which have gone up and down since 2023 to 2025. Okay, I can kind of make some analysis and what are the daily returns. Okay, this is like kind of very dynamic library where I change the name of the ticker and it will give me those. So I can go ahead and I can change it to TSLA, which is like Tesla. And if I want to know the Tesla prices from the last 2 years, okay, and it gives me this. This is how the price of those stock market is. It gives all the trends and everything. It's more useful in some kind of financial analysis and all. So yeah. So with that, we come to the conclusion of pandas. Pandas, you can do a lot of functionality. The most important part of pandas is the data frame. Once you have your data in a data frame, you can do a lot of operation on that. Okay, yeah, so that is it for this particular session on NumPy and Pandas. So are there any questions?
No questions so far. Participants can ask any questions, clarifications, anything related to data analysis. NumPy and data frames are way to do, Pandas are ways to do. Can you please ping code which you have executed in last? We will share the Google Colab links at the end.
Yeah. One thing I forgot to say last time is that is my screen share still on, right?
Yes, it's still on. Yeah.
Yeah, I forgot to talk about this GitHub where I actually created this Python bootcamp.
Okay. Mm-hmm.
Okay, I've added the Google Colab notebooks here from last session 1 and session 2. You can go and check this out. I'll have this in the comment. I'll add this session's code, this whole everything, like whatever there is there in this notebook will be added into this particular repository. Okay, and you can use that to again practice or try to understand the whole code in that. Okay, I have pinged it in the chat.
One question regarding when we import the libraries like NumPy or Pandas, then the aliases that you use, are they defined or they are like variables you can put it as per your choice?
Yeah, there are like variables. You can put anything. It's not necessary you have to put as NP or PD. You can put anything which is easier for you to understand.
Got it. Thank you.
And one more question, the ticker, the website whichever you gave, do we need to provide the link there or just the name? It will automatically.
Yeah, this one you don't have to provide the link. You just have to provide the name. So the internally that library does everything for you. You only have to give the name of the stock here, and it will go and pick it up. Okay. So I don't have any other names right now. So you can add any of the US based stock, and it will give you those stock market prices. And the reason is like, yeah.
Is it picking from any particular website or how is it?
Yeah, it is Yahoo Finance. So
Yahoo
Yahoo
Finance.
Yahoo
Finance
Finance you
do that
mentioned. Okay, fine, got it.
option.
Yeah, okay, yeah, thanks.
And lastly, you have mentioned yf.download. So download is exactly defined like the read function.
Yeah, correct. It goes there and then it reads those values and then it gives you the whole response and you can save it as a data frame.
Okay, so basic difference between read and download. Download saves in the database or something like that. Like,
It's more of like a data frame it will give you directly. So you can see this function. So if you are confused, you can hover over this function. Okay, like I'm hovering or do download, and it tells me what actually the download is. So it returns a union. Okay, here this is arrow, which means that this whole function returns a union of a data frame. So it itself is a pandas data frame. So
okay.
okay, you can always go into the documentation to dig deeper into things and like try to understand what does it return. Okay, if you just look at this function, you will not understand. Okay, you can think okay, it will download it to my local or something. But if you go deeper into this function, you can understand like what other parameters it takes and all those things, right? So it has a lot of other parameters and as well. So it returns a data frame in the end.
Got it. Thanks.
One question, if you can help, not scope of this series, Sumant, but if somebody wants to extend and learn data structures and algorithms beyond this, what is the way to do that? Any suggestions or any?
Yeah, just a second. Let me come.
Hello.
Yeah. Sorry.
Yeah.
You want to learn about data structures? Is the question?
Yeah. Yeah.
Hello. Actually, I have a question. Right now, I'm done with my basic Python, and I'm gonna start with DSA. So, like, my question was, should my roadmap? Should I do libraries first or my DSA first?
DSA first. Libraries, you can do it later. Like you need to have a good base understanding of all the data structures used in Python. And if you're saying data DSA, right, you need to understand the different algorithms and all. And once you are done with that, when you are applying all those things, you can use the libraries.
Okay. Thank you.
One question is, can Yahoo Finance, does it only do for US stock or can it do for Indian stock also?
I tried to find Indian stock. I did not find. So you can go and search around with that.
Yeah, okay. Okay, any other questions? Since it is about data analysis and data manipulation and data, we have somebody in the group who already has done Subramanian. If you seem to have worked on Tableau, Power BI, SSRS, very common question that many people have is no code, low code, and then compared to Python, which one should I start? Where should I go? Subramanya, can you share your experience on Tableau, Power BI kind of tools? Then we'll come back to Atharva, if you're okay.
Good afternoon.
Good afternoon, Subramanya.
Yeah, I'm working as a DBA. I use Power BI, SSRS, Tableau, all based on the our client's requirements.
Mhm.
These are all the data visualization tools. In addition to that, we can create paginated reports as well. We can connect to different data sources. Many data sources or files like Python, Sumant explained. We can read it from CSV or we can read from any other web pages. Or using API services, we can read from other services, etc. And create charts and publish the reports for the end user to view.
Okay.
So mainly all the tools comply with all these basic requirements. There are different flavors which each tool provides, like a desktop. For example, Power BI desktop or Tableau desktop, which we can, as a developer, we can create charts, dashboards, table view, etc., and publish it. Other layer is service layer, where we can create an account as a cloud environment, which provides. So we can create all this in the cloud itself, online itself, and publish it. So like that. All the tools provide both mobile view and desktop view.
Okay.
Yeah. Okay. So all the things we can use DAX expressions as well to make some kind of calculations, etc. DAX is a common data analysis expression concept, which is available across Microsoft products like Excel, Word, wherever. So in Power BI also we can use that. Tableau also provides compatibility with the DAX, and I think now it is giving compatibility to work with the Python libraries as well.
Okay.
So all these things. So these are all well done. Both are licensed one. Free for a free to get into hands-on. So we can create a free account by giving our email ID, etc., and use it for a few months. Tableau is giving 1 year of free access for a student.
Student. Okay.
Yeah, for a student. Power BI desktop is anyway it is free. We can, but only thing is with the free version we cannot publish the reports.
Okay. Okay.
So all these things are all are very much useful tools only.
Yes.
So, so I cannot say Power BI is better than Tableau, or Tableau is better than Power BI, something like that. So all based on the client requirements. All tools are the same. With SSRS, SQL Server reporting services, we can do all these things, but with limited features. Yeah.
Okay.
So
And what is your motivation to learn Python?
Python nowadays, everyone is talking about Python, right? Python, and I hear that compared to R libraries or language, Python libraries and languages super fast.
Yes.
So that's where I want to eager to learn that Python.
Okay.
But otherwise, just to have a knowledge on a new language.
Okay, excellent. Thank you so much, Subramanian.
Yeah. Thank you.
Yeah, Atharva, you want to ask the last question? We'll close.